one. Typical Common Core type question. You need to be able to read, and you need to be able to just kind of wrap your head around what's even happening here. So this asks us to algebraically prove that the difference of the squares of any two consecutive integers is an odd. So, first of all, let's start with consecutive integers. If you call your first integer x, what's the next consecutive integer? How do you get there?
X plus 1.
You just add 1 to it, right? No matter what integer you're on, to get to the next one, you add 1. So x plus 1 is the second integer. And you did stuff like this. I just have been working with some Algebra 1 kids up in the TLC, and I know they're doing this right now with consecutive integers or consecutive even integers. Let's pretend it said even integers. How would you get the second one? X plus 2, right? To jump from even numbers, you add 2 every time. So those are your two integers. This wants us to prove that the difference, subtraction, of the squares of those, that would be x squared minus x plus 1 squared. Does everybody agree that's the difference of the squares of those? Any questions on that? They want us to prove that this is, and what symbol do you use when you see is in math? Equals. Is odd. Now, odd is tricky because I'm just going to write odd for a second because I don't know even how I would do that. But this is what I'm trying to prove, okay? So as far as proving, the two-step process is simplify the left, simplify the right. We're not touching the right. Simplify the left. So we first have to square out this. Now, by the way, when we square this out, it's going to result in a trinomial, correct? And if you're subtracting a trinomial, you need to make sure you keep it in parentheses so that you don't forget to distribute the minus sign when we're done with all this. So that'll be x squared plus 2x plus 1. Hopefully we're getting better at doing that in your head. And then when you distribute your minus sign to continue simplifying, your x squared minus x squared is gone. You have negative 2x minus 1. So my left is simplified, my right is simplified, and do they equal each other? Not in the way that we're used to, for sure. But now I think your proof needs to be supplemented with like an explanation. How do you know that's always got to be odd? Olivia. Perfect. And that's all you need to write. Any number times 2, or in this case, times negative 2, is even. And if you then subtract 1, it'll become odd. Good. So it is kind of a mixture of an algebraic proof, but then I think it needed to be supplemented with some explanation as to how you're sure that's an odd number, and that was perfect. Okie doke. That will never be your favorite kind of question. This one here is going to remind you of what I went over on the spiral that was due yesterday. Do we see how, what expression is used multiple times? Lucas?
4x squared plus 5.
Right, 4x squared plus 5x. So, and it's repeated, and it makes this more complex. I am not going to square everything out, distribute my negative 5. It's not going to be easier that way. What I am going to do is I'm going to replace this with a different variable, y. So I'm going to rewrite this as y squared minus 5y minus 6. And I'll remember over here that y is what I used to replace that expression that made it more complicated. Because now if you guys are asked to factor this, can you do that? Go ahead and factor that on your own. I have a feeling we might run into a couple different answers here. Boy, let me go with Vince. How did you factor this? Y minus 6 and y plus 1. Did anybody use anything different? No? No one used 2 and 3? 2 and 3 makes 6 and adds to get 5? No? Well, that's good, because that would have been the wrong one. But this is one of those very rare, tricky ones where it kind of is tempting, because you do think 2 times 3 is 6, and 2 and 3 makes 5, so you'd think, but if you actually check that out, one of them has to be positive and one of them has to be negative. So you're always actually going to get a 1y in the middle, positive 1y or a negative 1y, depending on how you put the signs. All right, so that was good. So now it's partially factored, but obviously those y's are not part of the original problem. So we're now going to go back and bring our y expression back in here. So I'm going to replace this y with that 4x squared plus 5x again. Same thing on the second factor. And now each of those are trinomials that can be handled separately. So start on your own with the first one. Guess and check or split the middle term, whatever you got to do to figure out what you want that to factor into. And then I'll call on someone in a minute. If and when you think you have the first one, you also obviously have to factor that second trinomial too. Owen, where are you at with the first trinomial?
It would be 2x plus 6 and 2x minus 1
Okay, let's check that out. What's 2x times 2x? Is that what you wanted? Good. What's 6 times negative 1? Is that what you wanted? What's your outer? Well, we're checking foiling, so your first and your first worked, your last and your last worked, but your outer product, which would be 2x times negative 1, and what's your inner product? Do those two, 12x and negative 2x, make 5x? No, so you guessed, but you didn't check. Okie doke. Natalie, what'd you have? You had the same thing he did? Did you guess and not check? You can't just guess and not check, kids. Can't do it. Alexa, what'd you have? Okay, so maybe you don't want to guess and check, and that's fine. You splitting the middle term, right? So you needed two numbers that multiplied to get what? 24. Negative 24, right? Yeah. And added to get 5. What are they?
8 and -3.
Very good. 8 and negative 3. Does everyone follow that? So she's now going to split that middle term. She's going to have 4x squared plus 8x minus 3x minus 6. She split up the 5 into 8 minus 3. She's going to take out a 4x, left with x plus 2. She's going to take out a negative 3, left with x plus 2. Did it work?
Yeah.
What are my final two factors, Natalie? Say it again. Well, give me the whole binomial and the whole binomial. Say that again. Where's your, when we grouped, took out a GCF, grouped, took out a GCF. Now we have to GCF one more time. What GCF of these gets pulled out in front? X plus 2 and what's left over. So those are your two factors. Does that make sense, Natalie? Okay. So 4x minus 3 and x plus 2. Now, if you guessed and checked your 2x and 2x over and over again with a 6 and a 1 and a 2 and a 3, you would have found that didn't work. So you had no choice but to go to 4x and x. And so that gives you the 4x squared. Negative 3 times 2 gives you the negative 6. My outer here is 8x. My inner is minus 3x. 8 minus 3 is 5. Good? Someone get me right to the next answer because we don't have time to do that again on this one. Georgia.
I had x plus 1.
So let's just check that. X times 4x, good. 1 times 1, good. Outer is 1x, inner is 4x, 5x. Perfect. That one was a little bit easier because even though you had to choose 1 and 4 or 2 and 2, you only had a 1 and 1 as your option on the second guess. So just one thing I haven't mentioned yet. They wanted the product of 4 linear factors. Linear. Right now, once we got here, we had factored it into 2 quadratic factors. Does that make sense? And then each of those quadratics had to go further, so we had a linear, a linear, a linear, a linear. Does that make sense? Okay? So that's what they meant by that. All right. Your advanced factoring. We've talked about all of this already, so this is just sort of review. When you look at this first one, you have how many terms? 6. Is there a GCF of all 6 of them? Let's start there. No. So with 6 terms, we're going to use grouping, but we have a 2, 2, and 2 option of grouping or a 3 and 3. So you kind of just blindly start, and maybe you can quickly look at your 3 and 3. Does it look like that's going to work?
No.
Oh, I beg to differ. But rightfully so, because I have more experience with you. What I see is a 1 coefficient, a 5 coefficient, and a 6. And I see a 1, 5, and 6 on this one too. So to me, that's promising. What GCF can I take out of the first trio? Just a t. I'm left with t squared plus 5t plus 6. What GCF do I then take out of the second trio? 1. Did it work? Absolutely, because what's left in parentheses in both sides matches. So now when I look at this and this, what do they have in common that I can take out in front? They have that trinomial in common. So that trinomial gets brought out in front, and Sierra with an S, what's left over? T plus 1. So in this case, I think on yesterday's notes, it was 2 by 2 by 2 we did. And that's what worked for that one. This one, a 3 by 3 does work. Am I done? Maybe. Maybe not. Which one of those might be factorable further? The trinomial. So I'll try it. T and T. And 6, I can do 1 and 6 or 2 and 3. Which one will make 5? Given that they both have to be positives particularly. 3 and 2. So this ended up factoring into 3 linear factors. As opposed to here, if we stopped here, that would have been a quadratic and a linear. And sometimes that might be where you have to stop. But the quadratic was factorable further into 2 more linears. Good? Any questions? This one's just like what we were just working on. Do you see the repetition with that x plus 2? So I'm going to replace that x plus 2 with a y. And I'm going to keep this off on the side to remember that. But in the meantime, I'm just going to factor this trinomial into y plus 4, y minus 2. But I can't leave the problem like this. Again, the problem started with x's. It needs to end with x's. That was just an intermediate step for me to like more clearly focus on the trinomial. Now that I'm down to that, now I can bring my y expression back in. So I can replace my y's with the x plus 2, which will give me x plus 2 plus the 4 and x plus 2 minus the 2. And those can be simplified into x plus 6 times x. Again, this ended up boiling down into 2 linear factors. This one would have, I can tell just by the answer, this one would have worked out if you squared it, if you distributed your 2 and all that, whereas this one wouldn't have. You wouldn't have been able to get all that had you done that. So what I don't want you to do is take your time squaring things out, distributing a 5, only to find like, ooh, I can't do anything with that. So if you can recognize the repetitive nature of like a binomial or something that's being used, try to use this y substitution method. Okie doke? All right. Next one. Thoughts. Where do we start? Lucas B. Where would you start with this one? Beautiful. Take it out. Because otherwise it's tough. Because if you just started guessing and checking, m squared and m to the third, like we usually don't use a different combo of m's. So take out an m, we have m to the fourth plus m squared minus 6. Now I can guess and check on the trinomial. What's really the only way we're going to make m to the fourth happen? Right. M squared. And then we need to multiply to get negative 6, and we need our outer and inner to be positive 1. Who's got it? Haley?
Minus 3. 1.
What should it be?
-2.
Right, the negative on the 2, the positive on the 3. Very good. Because you want it to be a plus 1 in the middle. Good. Can any of those go further? M squared plus 3 or m squared minus 2? No. We're real close to being the difference of perfect squares, but we don't have it. So this factored into a linear, a quadratic, and a quadratic. Does that make sense? Quadratic has a degree of 2, plus another quadratic with a degree of 2 brings us up to 4. Plus a linear factor has a degree of 1. That brings us up to the 5 that this started at. And the last one. Oh, no, it's not the last one. I added 2 more for your enjoyment. There must have been a reason I added those 2. In 4, how would you get this started, Angie? Take out a 2, be a little bit more thorough. Take out a 2 and a... D. Not 2D, exactly. A 2 for the numbers, a D for the variables. Perfect. 2D is going to leave us with D cubed plus 3D squared minus 9D minus 27. And we're left with 4 terms to focus on that are now smaller. What's our method with 4 terms? Mike? Grouping. So again, I'll worry about this 2D at the very end. If I take my first group, what do I take out? Jack B? And what am I left with? D plus 3, right? If I take a D squared out of D cubed, don't I have a D? D plus 3. Next group, Jack Taylor?
-9.
What am I left with?
D plus 3.
Okay, what are my 2 factors in the next step? Tess? D squared minus what? Is that what you said? I don't know why I heard 10 for some reason. And thoughts here? Eric?
Can't you get a perfect square out of the D?
Perfect. So I'm going to keep my D plus 3 that's there, but my D squared minus 9 factors into what, Eric?
D minus 3D plus 3.
Beautiful. There's your answer. You'll probably see D plus 3 written more condensed with a little square after it since we have 2 of them. Your 2D out in front and your D minus 3. We have time for probably one more. These tend to trip kids up a lot. And I think it's the mixture of the variables. And it really shouldn't. It's still 4 terms. I'll do the first one. If I go to group these first 2, is there anything that can be taken out? No. So grouping in this order might not work. Again, switch the middle 2 terms for me. XY plus AY plus AB plus BX. That's going to potentially make things better. So we've already been used to switching terms around. Now when I group the first 2, Faye, is there anything I can take out? A Y, and I'm left with X plus A. Second group, Sierra with a C. A B, a positive B at that, and I'm left with A plus X. Are those matching? Yes. Addition order does not matter. So X plus A and A plus X are the same thing. So I'm going to bring that out in front. And I'm left with what, Elena?
X plus B.
Y plus B. Y plus B. Yeah. Good. Okay, so don't let the combo of variables confuse you. Your homework are these 12 on the back. Factoring quiz coming up on Thursday. FYI.